This is a video about uniform circular motion and how we can use it to generate something that looks a lot more oscillatory. When we did uniform circular motion before, all we did was looking at a kinematics case way back in Physics 1 where something was able to turn or move in a circle in that way, and we had the centripetal acceleration v squared over r, and that's really the only place we went with it. Now we can describe any kind of a wave motion that we are looking at anyway, right? If this is time and this is maybe x of t, if we've got a wave like this, mathematically we can model that as x of t equals some amplitude times the sine of omega t. Or if it starts on 1, we can say cosine. If it starts somewhere else, we can throw in a phase angle. So, maybe we have some kind of a phase angle in there. The point is we've got something that can be expressed in terms of sines and cosines. Now we can use that to describe a regular wave, but maybe we've got this other situation. I'm going to erase the phase angle, by which I mean set it equal to 0. What if this is the x motion? So if I've got like a coordinate axis like this, if this is the x motion, x versus t is going to go up and down. What if the y motion also looks something like that? And if x was sine, let's go with cosine here. Well, if this is y and this is x, then at t equals 0, I'm going to get y equals a. So here's an a negative a, here's an a negative a. At t equals 0, I get y equals a, x equals 0. At t equals, at omega t equals pi over 2, I get y equals 0, x equals 1. So I go here. At the next one I go here, then here, and then back here, and I just repeat. So what I end up with is circular motion. Now that might mean something to you, and it might not. The point being, when we have uniform circular motion, we can express that uniform circular motion in terms of waves. I'm going to show you one quick animation that does this too. So here on the left we've got this path that's tracing out just a circle, and on the right we're seeing what that projection onto the y-axis would look like. So maybe this is an object that's casting a shadow, and we are kind of tracing out the shadow over time. But we get this circular motion on the left, and it translates directly to wave motion on the right.